All right, welcome everyone to section 5.4. We're going to be looking at how to factor quadratic expressions. And what we're going to be doing is we're going to be writing a quadratic expression as a factor or as a product of its two factors. And what this is going to do, it's going to help us in so many other sections later on throughout the year, including what's coming up in the rest of this chapter, that it's just a really important section. So what factoring is it's really unfoiling a quadratic into the product of two binomials. Binomial meaning two, meaning there's two things inside of it. And we looked at this. We looked at problems like this. X plus 2 is a binomial because there's two items, and x plus 3 is a binomial. So we remember that when we FOIL this problem here, we get x squared plus 2x plus 3x plus a 6 at the end, and we simplify this down to x squared plus 5x plus 6. And this is our quadratic expression, x squared plus 5x plus 6. So what that would mean is if I was to take x squared plus 5x plus 6, we could factor it into x plus 2 and x plus 3. Remember, equality is a two-way street. If I write a product and I finish it and make the quadratic, I can go in the other direction. So things we could notice, we notice that 2 times 3 is that 6 at the end. And we notice that 2 plus 3 is that 5. And that's really the most important thing to look at when we start factoring quadratics of this type. But what we're going to start with is something called the GCF. And if you recall, GCF means the greatest common factor. And what we're going to be doing is going to be looking at an expression like this, 4x squared plus 20x minus 12. And we're going to look to see, is there anything in common between these three terms? In this case, I have a 4, a 20, and a 12. All three of those things have a 4 in common. So I'm going to factor out a 4. And if I factor out a 4, I take a 4 out of the 4x squared. This just becomes x squared. If I take a 4 out of the positive 20, it becomes a positive 5. And if I take a 4 out of the minus 12, I get minus 3. Note that if you were to distribute the 4 back inside the parentheses, you would get the original expression. Let's try a different one here. 9n squared minus 24n. Well, n is just like the variable x, so it's the same idea. I look at the two things, and I know 9 and 24 are both divisible by 3, so I can take out a 3. And I notice that both of these terms have an n in common, so I'm going to take out one of those n's. And I can think, 3n times what will get me 9n squared? Well, that's going to be a 3 and an n. And 3n times what gets a minus 24n? That's just going to be a minus 8. And there we have factored out the GCF. Another one here, we have 9x squared plus 3x minus 18. We notice that all three of these terms have a common 3. So we're going to factor out a 3, and we get 3x squared plus 1x minus 6. Now, we're not doing the unfoil part yet on these particular problems. We're just trying to look to see if we have a problem, we can simplify a problem by factoring out a constant or a constant and a variable, depending on the problem you're coming to. All right, now what about factoring as unfoiling? Now, there are 2 or 3 different versions. One version here is when a is equal to 1, and what I mean by a is when I have ax squared plus bx plus c. And if a is equal to 1, this is the easiest type to factor. And what we're going to be looking for are a couple things. One, we need to look for numbers whose product is c and whose sum is b. And just like I mentioned in that very first problem we did. So here we need to look for 2 numbers whose product is 7 and whose sum is b. And you'll notice in the textbook what they'll do is they'll say your factors and their sum. So factors of 7 are 1 and 7. Well, that's actually it. And you notice that 1 plus 7 is 8. So there's only one option. And when I get those 2 numbers that make these 2 statements true, I write that in my factoring. In this case, it's a positive 1 and a positive 7. So it's plus 1 and x plus 7. And that is actually it. That's factored form of that quadratic. So we look here. We have x squared minus 17x plus 72. So this gets a little bit more challenging when the numbers get bigger. And we look over here and we say, okay, what are the factors of 72? Well, we have 1 and 72. Well, that doesn't help. We have, because the sum there is 73. We have 2 and 36. Again, the sum there is 38. That's not quite there. We have 3 and 24. No, that sum is 27, so that doesn't work. Let's try 4 and 18. And 4 and 18 make 21, so that doesn't work. And if we went to a 6 and 12, and I'm pretty sure that I made a typo on this. Let's make this an 18, because I'm pretty sure that's what it was supposed to be. And because I'm realizing this shouldn't factor now. Okay, let's make that an 18. This should work now. We notice here that the sum is 18. And we have a positive product, this positive 72, but it needs to be a minus 18. And we can do that by saying it's negative 6 and negative 12. So we get the product of positive 72 and a sum of negative 18. And we get x minus 6 and x minus a 12. And that is your factored form. Now, I have quite a few of these examples because, like I mentioned, this is a very important concept. All right, so if you've noticed so far, this becomes just x and x. And I'm looking for 2 numbers whose product is positive 8, and sums to negative 6. So I know I have 1 and 8, but that doesn't work. And I know that 2 and 4, if I do negative 2 and negative 4, I will get a sum of negative 6. So I say, all right, that means it's negative 2, or minus 2, and minus 4, and you're done. Once you get the hang of factoring, the factoring actually comes out very quick. So here I want 2 numbers to multiply together to get a positive 12, but we'll add together to get negative 7. So if I look at that, that means I know that both numbers have to be minus to get a positive product and a negative sum. And then by looking at a few numbers, I know that 3 and 4 will add up to 7 and multiply together to get 12, so I get x is 3 and x minus 4. What kind of throws us a little bit is when we have both minuses here. So we need a negative product and a negative sum. So I know that if I was to take negative 4 and positive 3, or if I took negative 3 and positive 4, I would get a negative product of negative 12, and I need to add them up to get minus 1. Well, if I added the one on the right up, I would get a positive 1, but if I added up this one, I'd get a negative 1. Since that gets what I want, that's what my answer is. So I get x minus 4 and x plus 3. All right, one more here and we'll move on to the next type. X squared minus 14x minus 32. Looking for two numbers to multiply together to get negative 32, but we'll add together to get negative 14. So 32 is 2 and 16. And I need a negative product, so one of these has to be negative, and a negative 14 as a sum, which means I need more negatives, so I need a negative 16. So my factoring is going to be x plus 2 and x minus 16. All right, so this is for when a is equal to 1. The numbers usually come out very nicely as long as you have a little bit of number sense. 72 is obviously a little hard because we might not remember how to factor 72. But let's take a look at the next type. Oops, let's go here. The next type is when a does not equal 1, and this is the more challenging type. Here's the process. We're going to find the product of a and c. Then we're going to find two numbers whose product is ac, but whose sum is b in the original expression. And we're going to rewrite bx using those numbers that we just found. And lastly, we're going to do what's called factor by grouping, which is essentially using the GCF method we learned earlier. All right, so here we go. We get 3x squared minus 16x plus 5. So we need to do a little bit of a scratch work piece here. We have a times c. A is 3, and c is 5. So we get that to be 15. And then b is equal to 16. Let's not worry about the negative here for right now. And 16 is equal to 1 plus 15, which is the same thing as 15 because that's 1 times 15 here. So we're going to use those two numbers. Since we have a positive product and a negative sum, that means both of them are minus. So we're going to say this is 3x squared. And what we're going to do is we're going to split that 16x. We're going to say it's 3x squared minus 15x minus 1x plus 5. Now, you remember here that negative 15x minus x is minus 16x. So we didn't change the problem at all. We just made it look a little bit differently. And then you're going to factor using grouping in these first few sections, or those two sections right there. In 3x squared minus 15x, our common factor is a 3x. We're going to factor it out, and we get x minus 5. Right here, if there's a minus sign here, we factor out a minus 1. And if I factor out a minus 1, I get the positive x, but here I get a minus 5. Then I look at this. I look at this term and this term, and I note that they both have x minus 5 in common. And when I factor out the x minus 5, I'm left with a 3x and a minus 1. And that's the factored form for this original expression. Now, yes, this is a little bit of work, but if you follow the steps, everything will come out correct. Let's try again. I know that AC is equal to 2 times 12, which is 24. And I know that B is equal to 11. And I need to find two numbers whose product is 24, but sum is 11. And I know that 24 is 8 times 3, and 11 is 8 plus 3. These have to match. You cannot choose different numbers. Just because 6 times 4 is 24, you cannot use 6 times 4 and 8 plus 3 as two different things here. So what we're going to do, again, we're going to split that 11, and we're going to say this becomes 2x squared plus 8x plus 3x, splitting 11x into 8 and 3, plus 12. Then again, like we did in the last problem, we're going to factor the first two and GCF factor the second two. The first two have 2x in common, and I get x plus 4. And the last two have a 3 in common, and I get an x plus 4. Now again, remember, the whole point here is to get these two things in parentheses to be the same thing. If they're not, something went wrong. And then lastly, we look at this piece, and we factor out the x plus 4. And when we factor out the x plus 4, we're left with the 2x and the plus 3. And there we go. We have factored form for the 2x squared plus 11x plus 12. Let's do one more. One more where we have both minuses. All right, so AC is 4 times negative 15, which is negative 60. B is negative 4. So here's the thing. I need two numbers whose product is negative 60 and sum is negative 4. So essentially I'm looking for two numbers whose difference is 4. I know 60 is 4 times 15. That doesn't help. But I know 60 is also 10 times 6. And since I want a sum of negative 4, I need a negative 10 plus 6. And those are the numbers that I want, so those are the numbers I'm going to use. I get 4x squared minus, well, let's go plus 6x minus 10x minus 15. And then factor by grouping. My first group has a 2x in common. And I get 2x plus 3. Again, because there's a minus sign there, we're going to take out a minus. And they both have a 5 in common. And I get 2x plus 3. And there we go. We get the same parentheses. So we go to the last factored form here. 2x plus 3 times 2x minus 5. And there we go, we have that version complete. All right, so you notice I'm doing this relatively quickly. You remember that I have a lot of experience and takes some time, takes practice, lots and lots of practice. Last thing here is the difference of two squares. It's a very special type of quadratic, and it factors to a plus b times a minus b. So it's always good to know what are your square numbers. Square numbers are things like 1 and 4 and 9 and 16 and things like that. So if I was to factor x squared plus 9, I'm not going to go through the whole method like we did back at the beginning. I'm going to note that this is x squared minus 3 squared. And I'm just going to straight factor this into the x plus 3 and the x minus 3. And that really is it. When I see a difference of two squares, remember it's got to be a difference. It has to be a minus sign there. So the same thing goes for x squared minus 144. 144 is 12 squared, so I can write this as x plus 12 and x minus 12. What if a is not 1? Well, if a is not 1, we could look at it like before, but a lot of these problems are going to give you two groups of squares. And 4x squared, well, 4 is 2 squared and 25 is 5 squared. So I'm going to write it as 2x because the 2x times 2x will get 4x squared. And the plus 5 and a 2x minus 5. And there you have it. That's the factored form for that polynomial, or for that quadratic. All right, so leave you guys with this. I will see you guys tomorrow. I hope you learned a little bit, and I hope you study well.